Hi everyone, this is Mrs. Pettit again, and I'm here to walk you through a little bit of practice of everything you've learned so far regarding logarithms. The first section is working with finding the same base so we can solve same base equations. Meaning if we can find the same base to use on both sides, then we can set the exponents equal and solve for the variable. So in problem 1a, we need to find a common base between 9 and 3. So if we use a common base of 3 and rewrite 1/9 as 1 over 3 squared, still raised to the 2x, and leave the right-hand side as 3 to the 7x minus 1, then I need to move the 3 squared out of the denominator, so I'll give it a negative exponent and change its location, still raised to the 2x, and the right-hand side will stay the same for now. And then I'll use my power of a power rule, which means multiply the exponents. So I'll have 3 to the negative 4x equals 3 to the 7x minus 1. And now that I have the same base on both sides, I can set the exponents equal to each other so that I can solve for x. When I subtract 7x from both sides, I get negative 11x equals negative 1. And when I divide both sides by negative 11, I'll get x equals 1 over 11. In the next problem, we need to find a common base between 16, 4, 32, and 2. So I'm going to use a common base of 2, and 16 is 2 to the 4th, still to the 2x minus 5. 1/4 I can rewrite as 1 over 2 squared, still to the 3x plus 1. 32 is 2 to the 5th times 1 over 2 to the 1st, still to the x plus 3. Here I can use my power to a power rule, so multiply and get 2 to the 8x minus 20. I need to move the 2 squared out of the denominator, so I'm going to make it a negative exponent and change its location. 2 to the 5th stays, and again I need to get the 2 out of the denominator, so I'll give it a negative exponent and change its location. Here I'll keep my 2 to the 8x minus 20. Here I'll use my power to a power rule, and I'll get 2 to the negative 6x minus 2. I'll keep the 2 to the 5th and use my power to a power rule again and get 2 to the negative x minus 3. Now that I have all the bases the same, I can use my rules of exponents, and when I multiply bases that are the same, I add the exponents. So I'll get 8x minus 20 minus 6x minus 2 equals 5 minus x minus 3. And when I combine like terms, I'll get 2x minus 22 equals 2 minus x. Now when I add x to both sides, I'll get 3x minus 22 equals 2. And when I add 22 to both sides, I'll get 3x equals 24. And when I divide both sides by 3, I'll get x equals 8. In problem 1c, we need to find a common base between 9 and 243. So that will be 3. We'll rewrite 9 as 3 squared raised to the negative 2x. We'll rewrite 1 over 243 as 1 over 3 to the 5th, still to the 3x. And again, 243 is 3 to the 5th raised to the negative x. I'll use my power of a power rule on the first term and get 3 to the negative 4x. I'll get my 3 to the 5th out of the denominator by raising it to a negative power and changing its location. And then again, Power to a power gives me 3 to the negative 5x. So I have 3 to the negative 4x. Using my power to a power, I get 3 to the negative 15x, and still 3 to the negative 5x. Now that all the bases are the same, we can add the exponents when we multiply. So negative 4x minus 15x equals negative 5x. And I'll get negative 19x equals negative 5x. And so here, x is equal to 0. In problem 1D, we need to find a common base between 216 and 6. So our common base will be 6. So we'll rewrite 216 as 6 to the third over 6 to the negative 2a equals 6 to the 3a. Remember, when we have the same base and we divide, we subtract the exponents, making sure that we subtract with parentheses because that exponent in the denominator is negative. So it'll be 3 minus a negative 2a equals 3a. It'll be 3 plus 2a equals 3a. When I subtract 2a from both sides, I'll get 3 equals a. So the answer for D is a equals 3. The next skill we're going to review is rewriting exponential equations in logarithmic form. If you remember what that looks like, it's log base b of the argument equals the exponent. So it will be log of base 10 of the argument of 10,000 will equal the exponent, which is 4. So when I go to write, it's log base 10 of the argument, which is 10,000, equals the exponent, which is 4. And I just follow this same procedure every time. So log of base 4 of the argument 1 over 1024 is equal to the exponent, which is negative 5. So log base 4 of 1 over 1024 is equal to negative 5. And I'll just keep going. Log base 10 of 3 is equal to 0.4771. So log base 10 of 3 is equal to 0.4771. Log base p of 3 is equal to k. Log base p of 3 equals k. Log base a of 7.38 equals 2. So log base a of 7.38 equals 2. And finally, log base b of 0.0183 equals negative 4. So log base b of 0.0183 equals negative 4.